last time we saw how the lack of encryption around the username allowed one person to impersonate another in our application. This kind of thing you can prevent with encryption, which is what we are going to look at now. And then we will look at a couple other things. See here, with the couple other things. First of which is how to integrate with an external logging service, and then integrating login service. Login and logging are too similar to each other. And then how to maintain logs, because integration of logs into servlets is not something we have talked about. So this at the end of these three steps, we have basically a polished app with the very small feature set that we have kept so far. Okay, let's get started with encryption. Okay, so what is encryption? Okay, so perhaps we will, the best way is to actually just show you, right? Here I'm going to log in with our username ABC1, and then let's take a look at what the network shows. So we logged in, and if you see the login result that we got, the cookie, this time there is a uname, but the username is nothing recognizable over here, right? It is encrypted into this huge string, which is totally unpredictable. That is what we really want. So there is no way to even connect this particular username with any particular user, even if you recorded every single interaction that is happening with the application. That's the crucial part, right? Let us verify the unpredictability by looking at a couple immediate sequences of login and logout. So we do a login, and we see that there is this strange long string that I will copy just to show that it is unpredictable. Where should we put it? I'll just put it somewhere over here. Okay, so that was one string. Now let me log out, and then I will log in again. And now if you look, that this string is quite different from the previous one, although we had the same user ID in both cases. That's the main point, that even the same user ID results in a string that looks different. So not only is it encrypted, even the encryption itself changes every single time you log in. The reason you have to be so careful is because even when you encrypt, so let's see, here is a definition of encrypt. Encryption is a process that takes some data and produces another piece of data from it, such that it is not possible to go easily in the reverse direction. These functions are what are sometimes called unidirectional functions. So given a secret and a input string, you can produce an output, but given an output, right, in the absence of the secret, there isn't a simple way to go back. Suppose you followed this with the same secret, then it will cause a problem, because somebody could just keep a table of everything they saw and try some experiments, and with the help of these experiments they could manage to determine at least every once in a while, right, who a particular user is, if you are repeatedly using the same secret. That is what we are seeking to defeat. So as we will see in a little while, I'll show you how that gets done. It is done by a very simple idea called salting. Let's look at the details in a minute. Right. let us look at the details of how encryption works. We already saw the effect, which is to give us a different representation of username every single time we try to log in. Okay. Here is what the basic process constitutes. There are libraries in Java. Unfortunately, they are not. They are somewhat cluttered and they are not really polished to the point where you can just drop it in a web app and go with it. There are other collections of libraries like Apache Commons, which often offer some sort of wrapping around the libraries of the JDK itself, but it creates one more dependency. The alternative, of course, is that you have to write all this stuff, which takes time, and it is very easy to make mistakes in doing something like this. So it's better to use polished libraries if you have those. In any case, since we are learning how to do it, I'll just show you the details. The two key functions are, there is encrypt and there is decrypt, right? Oh, okay. I have got my names of the parameters somewhat confused. The decrypt function should take encrypted string, and the encrypt function should take a plain text string. In any case, it's just a spelling error. There is no actual mistake, but as you can see, it is indeed easy to make mistakes like this. So let's fix that, although it doesn't really matter very much. In any case, the main thing that goes on in these functions are that we create an object called a cipher. We pass this cipher a secret key and the plain text of interest, and we get an encrypted string back. Similarly, when you send in encrypted string, you pass in the same secret key to the cipher object, and then the cipher object returns a string with something added called a salt, and you can remove the salt by splitting the decrypted string at this at the semicolon character. The semicolon character, etc., is stuff that I have made up. Let's just see what happens. In any case, the point is, encrypted text comes in and the decrypted text is extracted. To see what goes on here, let me show you this code. So we will compile this crypt testing file, and then we have crypt ABCD, suppose. What it's telling us is ABCD was encrypted into this long string. When the encrypted string was decrypted, it gave us a string first, which is a bunch of meaningless things. That part is what is called the salt, as I will show you. Then a semicolon character, and then our original string. We extracted this original string, and then we print it as the original string ABCD. Fair enough, right? And because this is our test library, I had printed the result of the decryption, which is together with what is called a salt. All right. Let us see what that process is. What happens here is something like this. The cipher function is based on Java libraries. We use an algorithm, we use an encryption algorithm that is called Blowfish. It doesn't matter, there are a bunch of these things available, and you can try a few. There are various reasons to use one versus the other. That's not something, for instance, I am particularly an expert in, but you can ask around, and there is reasonably good advice available for what you should do in production. For most purposes, any old algorithm that is in the library will work okay as far as getting started is concerned. In any event, these three lines that I'm highlighting, they are basically things that the library asks us to do. There is not much more to be said about it than that. There are reasons why things are the way they are, but they are not especially important. In any event, we get two cipher modes. You either encrypt or you decrypt. and depending on which was passed in, we will do one of these things and return the result. Encrypt, here is what encrypt does. The first 3 lines of encrypt generate 16 random bytes using a class called secure random, which is available in JDK. Then, because these are arbitrary bytes, what we do is we encode it to look like a string, first of all. And then, if there happens to be a semicolon character in here, we replace that with a dash so that our little separator will work correctly. The result of all this is a string that we will call a salt. So next what you do is you take the salt, you put a semicolon. What we have done is, in addition to the data we are supposed to encrypt, we added some random number, and then we don't particularly care what random number it is, right? As long as it is a random string which is separated by a semicolon, so that you can on the way out just extract and throw away the salt, but keep the original data as it is. And so given the salted data, you finally take the actual cipher. The next thing you do is also equally interesting. A cipher returns just a byte array of output data. The problem is that these are any arbitrary bytes, but because we want to send the result outside, right, outside as in across the HTTP protocol, because the user is going to see it as uname, we need to make sure that it is not just any arbitrary bytes, but that it is a set of characters which is known to be safe. Safe in the sense that there are certain expectations of what data a URL can and cannot have, what data the headers of HTTP can and cannot have. This job is done by the 2 encoder functions. Again, the encoder functions are small wrappers on top of existing Java libraries. What the encoder does is it takes the base64 class, gets something called a URL encoder. Again, some more detail which involves without padding so that certain characters are skipped, and then finally the encoding is done. Base64 is a way to encode a series of bytes with plain text characters, and the 64 comes from we have our 26 lowercase and uppercase characters and some more punctuation characters. You put this together and you get a 64-bit a number with the base 64 essentially. That's what that is. And on the other direction, you have a web safe decoder, which also you get a URL decoder and then you decode the data, right? So now we have seen how you add a salt. The second thing is, on the decryption side, it is reasonably simple. You get the bytes, you get the web safe decoder, and you send the data out. The job of stripping the original data, we have left outside over here, but as I was explaining to you, I just realized that there's no reason why, in fact, it's incorrect to do this work outside. I should probably unsalt the data in the cipher function too, since I'm salting it in the cipher function. In any event, it doesn't really matter, a small mistake in the structure of my code. Okay, so that's as far as that code is concerned. And then you include this in a class called crypt here. And then the next step is you take our fair share code. What you then need to do here is what you then do is that in the servlet, based on a secret key, which we get from a configuration file, which I'll show you in a minute, you generate a new crypt object, and then this is where you use the crypt. Okay, so I've called this object a cryptor, right? When we are checking whether our user is valid, which is the time at which we are going to look at the cookie, you get the uname from the cookie and then you decrypt it, which gives you the plain text version of the string that we are looking for. Now the rest of the code doesn't need to worry about the existence of encryption. Similarly, that's when you receive a cookie. Similarly, when you set a cookie here, when you are setting a user cookie, at that time you use the cryptor to encrypt the username and put the encrypted username in the cookie. When we store a cookie, as we saw last time, we also store the cookie in the session so that you don't have to repeatedly visit the database. But in the session, we are free to store it unencrypted. It doesn't really have to be encrypted in the session as well. If we did that, then you would have to change the code to compare, decrypt it when it comes in and so on and so forth. That gets unnecessarily complicated for this particular use case. After all, the username is not a secret inside our application. It is supposed to be a secret from the users, but not from our application. There are times when you don't even want the application to know what the data is. For example, in case it is a number like a credit card number, then you make sure that the credit card number, as soon as you receive it, it is encrypted, and then that encrypted number travels through your app, and only at the point where that number has to go to some payment gateway or something, at that point you can decrypt it if you really need to, right? That's the general idea. That's why, so at the boundary, when you are setting the cookie and when you are checking the cookie, you do encryption and decryption, and that solves our problem. Let us summarize what we have seen. We saw that exchanging plain text information is dangerous, so you use encryption. There are two kinds of encryption. Symmetric encryption means the same key is used to both encrypt and decrypt, which is the kind of encryption we use in our app. There's another kind called asymmetric encryption, where you use one key to encrypt and another key to decrypt. That is used when exchanging data among two parties. And we are not going to do that, although we are going to exchange data among two parties. But you can read up more about it having seen the basics of symmetric encryption. All right. Let's look at the next step. One problem that has to be solved is that any encryption takes a key, and in our toy application, I just have a secret string called secret12, secret12. It's a 16-byte key because there are situations where you have to have those many bytes and so on. If you happen to use this kind of a library, the reasons why these kinds of restrictions are there has to do with cryptographic code, and cryptographic code is one of the most difficult code to write correctly because a small mistake can completely ruin the validity of your code. In any event, there has to be a secret key. Embedding such a secret key in the code is absolutely the worst thing you can do. But of course, this is just a test program, so it doesn't matter. In a web app, though, you cannot do that. There you want to do something different. And let's see what we do, what the problem here is. In this case, we don't store the secret key in the code. We get it from servlet context get init parameter, which means we must be getting it from somewhere from the outside. The question is where? Because key storage is a tricky issue. I'll show you some problems that arise. First, for sure, it should not be in source code, right? If it appears in plain text anywhere on the machine, technically it is vulnerable. But suppose you attempt to encrypt the key which you are going to use so that it doesn't appear in plain text on the machine. The question is then, who's going to decrypt that when it has to be used? You can have some people enter it, but then automatic machine startup becomes impossible, right? As a result, there is a chicken and egg problem here, where some key has to be secret in such a way that it can be used for other things, but then somebody has to know that key. One possible solution is to use a central key store which knows all possible clients beforehand, and sometimes people entering it also can be made tolerable depending on the overall setup of your application. Certainly in the beginning you don't need to worry about such things. You can always store it in plain text, but adjust the Unix user rights and so on, so that it's not easy to get at, right? There are other possibilities like obfuscation by storing the key in several parts with non-obvious names and so on. The point is that whatever you do, you have to solve it somehow, and at some point a person is involved or people are involved. It gets expensive and it also gets somewhat tricky. In any case, it's a question of risk. The higher your risk, the greater precautions you can take. For ordinary purposes, just storing it in as a root user and so on is generally perfectly adequate. There are other methods such as holding the key in memory and having in-memory processes extract it and so forth. Doesn't really matter. I just want to point out that there is an unsolved problem here, and a basically okay solution is perfectly fine as far as that is concerned. In our toy application, right, in our teaching application, we are just going to store it in web.xml, which is fine for teaching but not so great in other contexts. So here we have the secret key. At least it is not in code. Technically you should do better than this, which is you have a known absolute path which is crucially never touched by automatic deployment services, right? That's the one where you want a person to be there to at least put the key in at the very beginning of when you are installing the machine, or have some secure distribution process which runs when a new machine comes up. And under no circumstances should it be possible to check this into any form of source control. That's really the critical thing. Once you have that much, your encryption is fundamentally okay. Alright, so that's as far as. Our next topic is the integration of logs. But before that, let me just touch upon one important point. We have done two things in the crypt library. One is we have done encryption, and the second is we have done base 64 encoding, right? Base 64 encoding is not encryption. Inexperienced programmers will sometimes mix the two, so I'm highlighting that as something you should never do, because base 64 encoding is just like using, instead of writing a sequence of bits as 8-bit numbers, you are writing it as 64 as base 64 numbers. Okay, let us go to our next part, which is how to integrate logging in servlets. To integrate logs in servlets is generally pretty simple. So for example, what I have to do here is webinf lib. The library has to have these log4j classes: API, core, web, and probably app server, although I'm not completely sure about that. There is something else that came up in the XAMPP code, which is that Tomcat in the installation was skipping over these libraries for some reason. So I had to go and fix this particular strange problem. I had to go to the Tomcat XAMPP Tomcat conf catalina.properties, and there is a list of jars to skip over, and I had to remove log4star.jar from there. If you look at I found this out on the web on the Tomcat configuration web page, but it's kind of tricky and it took me some time to understand what was going on. In any event, these kinds of silly problems are always there with using anybody else's libraries and even your own when you make mistakes and you will forget. But in any case, once you are past that point, then it is reasonably easy to use the logger. What we have is, let's see, fair share final. And how you fix that once it is there is that we have this logger class and you create a private static log4j logger and get the fair share logger. If a long time ago when we first looked at logs, I had shown you the config library. The config library has to be in webinf classes, because that's the class path, and you know, that's where you are supposed to keep the XML library, XML configuration. And then if you look at it, we have this logger called fair share, which we get over here. That gets us the log4j logger. But then we also wanted to, we also use the rolling file logger, so that the every 24 hours or so a new log gets created, so that every day's log is distinct, easier to find out what is happening today, right? And then the other thing we have to do is, if you recollect, in the web XML over here, we have something called a web page logger, which we had created. Back then we were looking at CGI libraries, and so getting data into the web page was identical to making sure that you were writing to system.out. That is how CGIs work. But that is not how servlets work. They don't bind their standard output in this fashion. And unfortunately, there is no ready-made web page logger, web page appender that is available in Tomcat. It is possible to write such an appender, but appenders in log4j2 are somewhat convoluted. So instead, what I did was to take a shortcut where I just write a class called weblogger, which has the same functions as the normal logger: debug, trace, etc., etc. That logger wraps around the log4j logger. It takes a print writer, which is the print writer.out. So just to remind you, there is a print writer called out, which we get, that we actually write to in order to get output into the web page. So this writer, I stick it inside the logger, and then I have a control which says whether or not you should log to the page. And I've done something dead simple. You send the incoming command to the standard logger, but also write it to print to page. And what print to page says is, if I'm supposed to log to the page, then find the log level. If my current level is less specific, there is this idea called specificity, then send that line to the print writer. So straightforward. I'm just literally taking the output and sending it in two different directions. We could have, as I said, done an appender, but for now this is good enough. The end result of all this is that our logs can now go into two places. Let me show you what happens over here. So if I just refresh this page and I look at the inspector, look, this page is clean. There are no logs in that page. But if I look at this output window over here, there is an output window. Okay, it's right. Let me just show you that. In fact, logs are getting generated. So, and the output window is Tomcat's own window. As you can see, logs got generated, right? So the logs are getting generated. They are going to this window, plus they are also going here to the fair share log. Let us verify that as well. Right. Okay. Anyway, okay, it got flushed a little late, so we are seeing it now. There, finally. So as you can see, the logs are going to two different places, but they are not coming to the web page. Why is that? Because I have this boolean which says whether or not I should log to the page. And the point is that you need to control that boolean. So first of all, when do we write to the page? We write to the page only when a developer is looking at it, because a developer would like to see what happened at this request right away, instead of having to look at the log files all the time and running grep and all these processes through that. Therefore, what I do is something, let's see, so page log. What was the name of that thing again? Weblogger page log. In this function, I'm creating a logger which gets a request and it gets the print writer. It first gets the log level from a cookie, and that is how I can let a user have control over it. Once it gets the log level, it says as long as the log level is not null and if the log level is debugged, then I'm going to create a new web logger, and the print to page boolean is sent to the web logger, right? Prior to using the web logger, I can still use the log4j logger, because the web logger is a wrapper on top of that. And after I have generated the new logger, then I can write about what the current log level cookie is. If you look at this code here, you will see that from time to time we get this log level equals null, and the L4j logger says log level equals null. So the log level cookie is currently not set. Question is, normally we set cookies via the server. How are we going to do that now? We would have to add a new button or something like that, which is too painful. This time I'm going to show you a pretty interesting thing that can be done. There is something called a bookmarklet which you generate like this. You create a bookmark and get the bookmark into the bookmarks toolbar over here, and then you can edit this bookmarklet. But here is something interesting that is not appreciated by many people. Just as you can have HTTP and FTP and these kinds of protocols for a URL, you can actually have JavaScript as a protocol. This is a really peculiar idea, but you can actually have a URL which is nothing but a JavaScript function. So to see what this function is, let's take. These are our two bookmarklets. Bookmarklets are JavaScript functions, and in JavaScript you can, by the way, this peculiar syntax is, there are various strange JavaScript things. In any case, this particular code will do the following. It sets a cookie for the document, and we can set it as log level debug. And then the second button, which clears the cookie, says as usual the log level cookie has nothing and it expires in 1970, right? We remove a cookie by setting its expiration date in the past. Although this looks like an assignment, it isn't. It adds a cookie to the existing cookies, and the assignment which looks like this removes existing cookies. Okay, JavaScript and the web are full of peculiar things like this. That's just the way the situation has evolved. Alright, now let us do this. So I'm setting the debug cookie, and if I look in the cookie manager, I have log level equals debug, right? And then my strange username and so on. And now if I refresh and look at the inspector, the refresh is blocked for some reason. Alright, we have the current page, and now we are going to set the debug cookie. Now if I get this report page here, you can see that I have logs appearing in the page. If I clear the debug cookie and then ask for the report again, there are no page logs. Right? Thus, by doing this, we are able to very simply control the behavior by clearing and setting a simple debug cookie using bookmarklets. And okay, this is all very good because it's a pretty interesting use of a cookie to control the state of the system. But as soon as you do that, you get a security issue. Ideally, you should allow a debug cookie only from authenticated developers, such that they come from, for instance, internally known IP addresses or have another sort of developer token cookie somewhere there, right? In general, every decision we take about our app that affects users, including programmers and maintainers, any such new feature needs to go through the security lens. Otherwise, if the nature of the cookie goes out, absolutely anybody on the planet can set such a cookie, and it will have some effect. Now, will it help whether they get some debug material in the web page? Maybe, maybe not, who knows, right? But you never want to assume that things will go right. It's better to assume you allow things that you want rather than and basically disallow everything else. That's the general style of design that is needed in this world. Next, let us look at the addition of a remote login service. To do this, first we will log out, and I will actually start. Right, so I started the manager. Notice that I have added a new application here called the login service. We will look at what the login service does. The main point is that I will be now able to visit a URL called a login service. If I just try to call it, something interesting happens. It tells me that this is an authorization service only. So the server understood that I requested a slash, but then it refuses it because that is not how this service is supposed to be used. It is designed to be used only from an application like this. This is our first example of where we have actually used HTTP status codes to indicate certain kinds of behavior that the application is supposed to do, right? This is our first example of composing two HTTP services. Alright, now notice that besides login and register, we have a login service button, and the behavior which we are going to expect looks like this. It's better to understand the back and forth first. So first, browser visits fair share, which is what we have done here. And then there is a login service button which is offered. This button takes us to an external login. Let us see how it does that. Let me just walk through this and then we'll look at each step. So at the time you press the button, the fair share app will ask our browser to go somewhere else. Right? We are not directly doing anything. We are asking the browser to go somewhere else and log in. The browser then takes you to the login service. The login service, if you succeed in logging in, will actually redirect the browser back again and say that now you should visit fair share back, but with a special URL which tells the FareShare app that an external service has logged you in. And then that means you visit FareShare via this special endpoint called external login. When FareShare receives the external login, it behaves exactly as if you had logged in normally, which means that it takes you to the first screen that you would otherwise see. Fair enough? Let us now look at the details. So I hit login service and I made a mistake. I should have seen the network. Okay. Let's just start all over again. It's easier that way. Okay, let's go back here, look at the network. Okay, everything is clean now. Right, hit the login service. Okay. So I posted to FareShare final, right? And the thing that I posted was, the request that I posted was a button called EX login. Okay. Then what FareShare did, it redirected us back to this complicated looking URL. Right? The URL is the URL of the login service with a request that says authorize ? With these parameters. This is our first example again of a get URL with query parameters. What are the query parameters? We can look at it here or you can look at it over there. Let us see what all we have. We have first the login service, then authorize ? OK URL. Alright. So OK URL means if you succeed in logging in on the remote service, what should you get back? Right now, we have not provided any name at all. Okay. We actually need to provide a name. I will show you that in another step, but this is just to clarify what is happening. You are also supposed to tell the service which user you are trying to log in as. And then there is a back URL in case the user changes their mind and merely wishes to go back. So first let's hit go back. Alright. Now I wish to log in as the URL ABC1 and I hit login service again. Now let's see how the URL has changed. The URL now has the OK URL now has exok user equals ABC1 over here. It also says the site user is supposed to be ABC1 and the back URL remains unchanged. What I'm now supposed to do is put ABC1 over here and some password. In this application, I'm not even going to look at the password. But let us say that, so by now we were at the browser. The browser took us to the login service, which is where we are, via something called authorize. See, if you don't go here with the authorize key, then what you get is authorization service only. The server understood the request but refused to authorize it. But because you arrived at via the authorize URL, then it accepts and shows you this form. You have ABC1 as your user, so now you are going to log in. At this point, the login service is going to issue a redirect which takes us back to FareShare, right, via the exok URL that we ourselves. So FareShare sent a URL which is a callback URL which says if you are successful, come back to me with a URL that I have specified. Okay. Suppose now I succeed in logging in and I am back at users just as usual. So what happened was, see, I got here via exok and then exok did two things. It first accepted that, then it is now telling us to set a cookie because this is a normal login and we have our standard encrypted cookie now. This encrypted cookie is what we will use going forward. So the next thing that happened was we got another get request here and then the get request said go back to /users as usual, and now you are just a normal user. Thus, we didn't log into this site directly. We went somewhere else, logged in there, came back as a valid user. And because that jumping back and forth is agreed upon between those two sites, it was able to say that I will accept the login that happened on the other side as valid. How did it know it was valid? The answer is that a specially crafted URL called exokuser was received. Now, we went to a great deal of trouble to tell you that you shouldn't transfer usernames like this in plain text. In a real system, that's what we would have to do. But now there are two parties here. There is FareShare and there is the logging service. If FareShare wants to transfer information safely to the logging service, it needs to use asymmetric encryption, meaning you have to encrypt the information in such a way that the logging service can decrypt it, and in turn the logging service has to send information to FareShare in such a way that FareShare can decrypt it, and only FareShare can decrypt it. In fact, the way this works, the public key cryptography or asymmetric encryption, that the FareShare application can first encrypt the information it wants to send in such a way that not even the FareShare application itself could decrypt it. Only the logging service can decrypt it, and the other way around. How this works is, the logging service will share a key called a public key that anybody can use to encrypt information intended for the logging service. And similarly, FareShare will share a key with the logging service that says that here is a key you can use to send information safely to me. And in this way, going back and forth, you can actually achieve external logins. Many payment APIs, banking APIs use even more sophisticated versions of this sort of information exchange. And all of us have this experience, right? You can always go to Flipkart or Amazon or whatever and pay via your bank. And that's what they are doing. They're taking you to the bank is sending you back, and so forth. This kind of jumping back and forth is the core of remote payment services, remote logging services, and so forth. Right. So, HTTP redirection is a way to compose services in a flexible and distributed fashion. You have to pay careful attention to security, use various forms of asymmetric encryption, tokens, etc. And OAuth is a standard API which works that way, but banks and payment platforms offer their own so that they have control over what goes on, right? Okay, so that's our session for today, and now the FareShare app is fundamentally complete. It's doing encryption, it's doing logging, it's doing remote service. Those are the core things you need besides the actual problem to be solved by the app. Okay, and the next lecture will be our last lecture, in which we will quickly go over what we have seen before and talk a little bit about some ideas you will need in the future. Before we go to the next session, I just realized I hadn't done something. So let's look at that remote login again. We have our browser which visits FareShare, which redirects with a callback to external login, which redirects with a callback to FareShare again, right? Let me just write down the URLs so you have a reference here. So we initially visit localhost 8080 FareShare final. We get a redirection to localhost login service authorize. If you go to the login service without the authorize part, then you get this authorization service only failure, right? Otherwise, you get a behavior where the login service shows you a form. Alright. Now, if the login succeeds, then the login service redirects back, I should say, login service redirects back to the URL which we ourselves specified, which is this OK URL. Okay. And that URL happens to be this type of URL, exoku, etc., etc. exoku equals. And if you happen to come properly to this URL with ABC1, then I just hit login. ABC1 login service. You can see that the URL we say is exoku equals ABC1. So this URL here, the URL here. And now when that redirection happens, so we are going to do that redirection. What happens is you go back to /users, right? Because it looks like a normal sort of login to us. So fair share processes. Okay. Let us also tie this together with the structure of the code. Let me do that. Okay. So you come in and the URL happens, the path happens to be exok, right? As usual in web, we need to add the path to web.xml, and we need to say that in all cases including exok, you should still come to the app. And from the string we extract u, which happens to be ABC1, and then we agree that we are going to set a user cookie, and you send a redirect, right, to /users. So that is what is going on at this point. The other part of the process, which is right, in the do get, we have processing of exok, and the second part is what happens when you first post. So you visit over here, and then I should say press the key, press the ex login button, extra login service button. So or more properly, post the login service request. And let us see how the login service request gets processed. So we have in post we have ex login. And what ex login does is it gets the username, it constructs the URL. Then in constructing the URL, after getting the username, it gets this ex login URL. The ex login URL is stored in web.xml here with the name login service URL, which you access with get init parameter, and the URL is all the pieces with some blanks. So the blanks are this part UU, where the username is supposed to be inserted. And we are using %% as a placeholder for these AND signs, because the AND sign has a special value in XML. I could have used something called CData, which is a XML feature to allow characters like AND. However, in this case, in any event, we are going to do some string processing. So it's simpler to just make something up like %%. And when you get the value, replace all the %% with and replace all occurrences of UU with username. Once you have the URL, you send the redirect, which is what we do at this point. Let me just maybe put here some value user. and then well, no, that's not. OK URL is more complicated. Okay, this is good enough. Right, so that's the part of the code that does the job of remembering where to post and so on and so forth. So in this way, we construct a protocol for interaction between two different sites. And then the rest of the stuff we talked about. So that's fine. I think I have covered everything that I wanted to do in this remote login service business. So all in all, we did three things. We looked at encryption, we looked at remote login, and we looked at logs and how you can get logs to show up in the web pages using bookmarklets. All right, so I think that's it for this part.